Oh, it's February 8th. Valentine's Day is only a few days away. I was only a scalar until you came into my life and gave me direction. You are the vector of my heart. How is that not a Valentine's card? That should be a Valentine's card. No? Okay. Example 1, a person walks 6 kilometers north, 4 kilometers east. As soon as I see 2 different compass directions, I have a habit of saying to myself, okay, I better draw a compass rose somewhere on the page because that's a no-brainer, silly mistake that I can prevent by doing that. For me, the big one, and I think you saw it once already, I get east and west mixed up all the time if I'm not concentrating really hard. What's the distance this person traveled in your heads? And you'll notice I only gave you one line. That's my hint that you can do this in your head. Owen, what's the distance this person traveled? No. What's the 10? And no, distance is a scalar. So north, no direction, please. D equals 10 kilometers. Now, what's their displacement, magnitude, and direction? Now I've got a DULP. And so I'm going to draw a vector equation. Owen, what's the first vector, magnitude, and direction? So I'm going to go that plus, what's the second vector, magnitude, and direction? Is 4 bigger than 6 or smaller than 6? Half as small or not quite half as small? I try and draw my pictures, Jordana, roughly to scale, just so that, for example, don't write this down. If I'm finding an angle and I get 8 degrees, that would creep me out because that doesn't look so small. Or if I get 82 degrees, that would creep me out as well. I want my pictures to look roughly to scale. So I would draw 4 a little more than half as long. I don't know, about there maybe. Oh, and how do I add these 2 vectors together? So you could either go 4 plus 6 or 6 plus 4. I don't care which one you do, just so that our work will look fairly similar. Almost all the time, Jack, I'll go in the order that they gave me the stuff in the question. Since they mentioned the 6 first, I'll draw the 6 first. Then I'll draw the 4. And the resultant is from the tail of the first to the tip of the second. Everybody have a calculator here today? So they're going to power off their phone and I will give them a loaner. Solve this. Oh, first of all, where's the theta going to go? Bottom left or top right? How do you know? Always where the vector is coming from, not where it's pointing towards, where it's originating from. So theta is going to go right there. Color, 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 color. Are we finding a hypotenuse or are we finding a side of the triangle? We're finding a side of a triangle? Or are we finding the hypotenuse? Let me say that again. Are we finding the side of a triangle? Or are we finding the hypotenuse of the triangle? Is that the yeah, we're finding the hypotenuse. So for Pythagoras, is it going to be 6 squared plus 4 squared? Or is it going to be 6 squared minus 4 squared? Okay. I don't know how good you are getting at this stuff, but I am going to be bold and just go 6 squared plus 4 squared square root on my calculator and not actually write that step out. On a quiz or a test, Davis, I would absolutely write this step out too. But for now, 7.21 kilometers at opposite, adjacent. I think it's going to be tan. .7 degrees. North of south, east of west, what of what? I can't hear. I think you're right. East of north. Sorry. Can't write the word of. Or 90 minus 33.7, or 56.3 degrees north of east. But if all of us did the 6 and then the 4, we would all get the same what of what. But I would take both. Is that all right? Good. How do we subtract vectors? The short answer is we don't. Instead, we turn it into an addition question. And Sam, the way we do that is we add the opposite. And here's what I mean. Next to here, if you want to, you can write 5 take away 7. Grace, if I want to change that into an addition question, that's the same as 5 plus the opposite of 7. Those two are the same answer. There is a rule for subtracting vectors. You draw them tail to tail, and then it goes from the tip of the longest vector to the tip of the shortest vector. Emma, why memorize a different rule when I can, how do you add two vectors together, Emma? Draw them. When I can turn it into that. So if you give me vector A minus vector B, I'm going to go, that's the same as vector A plus the opposite of vector B. Now, what do I mean by the opposite of vector B? If vector B originally points north, what's negative north? South. What's negative west? East. What's negative east? West. Just be really, really, really careful when you're subtracting vectors, because now it's really easy to accidentally point something in the wrong direction. But then once you've done that, then you add those two new vectors together tip to tail. So, example 2, I've just turned the page and I see compass directions, so I'm going to draw a compass rose. I think you folks might have one somewhere else on your page, but I'm going to do that. If F1 is 6 newtons due west, and F2 is 12 newtons due north, what's F2 minus F1? I'm going to be really meticulous here, Em. I'm going to go like this. F2 plus the opposite of F1. And I'm leaving spaces because underneath each one, I'm going to draw the vector, and then I'll add them tip to tail. Emily, what's F2, magnitude and direction? So that's going to be 12 plus. What's F1 as they gave it to me, magnitude and direction? So what would negative F1 be? 6.8. I can't hear. The opposite of west is south? Okay. By the way, it's also easy to say, oh, don't I flip that? No, 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 no. You flip the second one, and this said F2 minus F1. So negative west would be east. And 6.8 is roughly half as long as 12, so I kind of eyeballed it about like that. Now I've turned it into an addition question. Emily, how do I add two vectors together? Draw them. Good. Solve this one on your own. I'm going to shut up. I'll erase you. Now, that would normally be Timbits, whoever's phone went off, but we can't do that this year. But make sure your phone is on vibrate, please. And when I'm not sure what to call the final answer, I use a subscripted R for resultant, because I know that's what you call whatever vector sum. So FR is the resultant force. In this case, it's a subtraction. Is it? Am I right? Is it 13.8 newtons, 29.5 degrees east of north? Okay. By the way, if you just said northeast or east-north, that implies exactly 45 degrees. So you have to put a theta there, unless by a fluke it is exactly 45 degrees. But I would still put the 45 degrees there. We're good? Where would you use this? That's a good question. I like example 3, I like example 3, I like example 3. Example 3 is a nice question. Normally, Davis, example 3 for my students is kind of a yawner, because normally in physics 11, I would have done a unit where I pounded this into your brain, much like get the obvious one, much like this is a job for a free body diagram, much like tip to tail this year. I would have said, okay, if V final is 36 meters per second north, I've scrolled down, I'm going to draw compass rose because me. And V initial is 17 meters per second east. First of all, what does that triangle, that delta, mean in science, in physics? Change in. And had I had a normal year with you last year, I would have flogged into you, what's change in anything? So Alex remembers, final minus initial. You might want to add to your purple sheet that means final minus initial, or you could even say that equals, quote, change in equals final minus initial. That's one of the places where you'll end up subtracting vectors if you're finding the change in something, because the change in anything is final minus initial. Now, if it's a scalar, you just go final minus initial. But if it's a vector, you're subtracting vectors. How do you subtract vectors? We don't. We add the opposite. So if I want to find the change in velocity, delta V, that's going to be V final plus the opposite of V initial. Is that okay, Davis? What is V final? Magnitude and direction. Yeah, you. What's V final? Magnitude and direction. Read it. So if I write that, let's go like that maybe. Plus. What's V initial, magnitude, and direction as they gave it to you in the question? So what's negative V initial? 17 meters per second. And 17 is a little less than half of 36, so I'll draw it pretty short. Have I turned it into an addition question? How do I add two vectors, Davis? Draw them. Now, I've got to kind of think this through. Look up for a second. I'm imagining what the triangle looks like. I'm not going to go like this, because now if I do that, I'm going to run over my equal sign in my work. I realized because I've got to go to the left, I'll start out with the 36 over here. I'll give myself some room. 36, 17. And there is delta V. Where's the theta going to go? Top left or bottom right? Bottom, where the vector is coming from. Color, 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 color. Yep. That's a great question. Okay. How are we ending up west when nothing is going west? Okay. This is asking what the change in velocity was. Which way was it going originally? What's VI? Magnitude and direction. Okay? So I'm going to use my little airplane analog here. Here's my ruler. Here's the wings. Airplane is going which way? East. Which way did it end up going? For it to end up going north, it has to cancel out the east by somehow getting pushed that way to the west, and it's also going to have to get pushed up to give it some north component. So that's where that west there, that's saying first you've got to cancel out if it ended up going north, you've got to cancel out the east and push it north. You've got to cancel out the east and push it north. How do you cancel out the east? Push it west. It's a great question. Okay. In fact, really, change in velocity divided by time is acceleration. And F equals what? MA. If you want to stop a plane from going east and you want it to end up going due north, which way do you need to push it? West and up. West of north. It's a great question. First time in a few years a kid's asked that one. You got me psyched. I was like, will they ask? Vector components. Not only can I add two vectors together and turn them into a single vector, I can give you a single vector and I can say, what two nice vectors did it come from? Now, if I just say what two vectors could it have come from, there's an infinite number of answers. What I really mean is, what two nice vectors did it come from? We call those its components. In fact, typically we refer to vertical and horizontal components. And I'll use a lowercase y as my abbrev for vertical, because the y-axis. And I'll use a lowercase x as my abbrev for horizontal, because the x-axis. So example 1 says, find the vertical and horizontal components of this vector. I guess we've launched something at 42 meters per second at an angle of 38 degrees. And you could either call this north of east, or if we were looking at this from the side, we might say above the horizontal, pointing up. I want to find what two vectors this came from. Horizontal and vertical. And the way I'm going to do that, I'm going to draw a little horizontal dotted line like this, and I'm going to call it Vx. I'm going to draw a little vertical dotted line like that, and I'm going to call it Vy. V for velocity, because it's meters per second, X for horizontal, Y for vertical. I'm going to color. And I'm going to find the magnitude of Vx and Vy. Doesn't matter which order I do them in. Petco, what do you want to find first, Vx or Vy? I don't care. Vy? Okay. So the side that I know is the 42, so I'm going to use these two. Don't circle yours like I just did. That 42, Petco, opposite, adjacent, or hypotenuse? What about Vy? Which trig function? Ooh. You know what? I'm going to go SOHCAHTOA. There we go. Which trig function? Sine. What always goes next to the trig function? Which in this case is 38 equals what over what? More specific in this particular triangle. How would I get the Vy by itself? I'm not going to swap the Vy over. I'm happy with where it is because it's on the top. I'm going to move the 40. Yeah. Vy is going to be 42 sine 38. And I get 25.85778. All right. You know what? I'll carry a few extra sig figs. 25.858. Is that right? People nodding? Okay. Petco, Vx, opposite, adjacent, or hypotenuse. Okay. I just found Vy, Petco. I could use these two. Why would I try and avoid doing that? I might have made a typo here, so I'll use the 42 that they gave me. Which trig function, Petco? A and H. Vx over 42. How would I get the Vx by itself? Hey, Petco, are you saying that I can just backspace and change the sign to a cos and not have to retype everything because everything else is exactly the same? Well, that's gonna, I'll do that. Less typos, less typing. And I get 33.096. What I'm saying here, Grace, is moving at 42 meters per second at an angle of 32 degrees above the horizontal or 32 degrees north of east is exactly the same as moving 33.096 meters per second east while at the same time moving 25.858 meters per second north. And I can even do the Pythagoras to show you. If I go 33.096 squared plus 25.858 squared, and then I take the square root of that, I'll get 42, or really close to it. I've rounded off a little bit, so I didn't quite get my original answer, but pretty close. Now, why would we do that? It's much nicer to deal with things horizontally and vertically than to deal with things at an angle. If I can avoid dealing with things at an angle, I'll try and do that. Example 2 says, find the components of this force, horizontal and vertical. I guess I tend to almost always draw horizontal first. And then there's vertical. I'll call this Fx. I'll call this Fy. Jack, do you know what's next? Color, 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 color. You don't have to, but it's a habit. Hey, Jack, that Fx, opposite, adjacent, or hypotenuse? Opposite? That? I think I disagree, because look, I think that's opposite. So Fx, oops, erased too much. Fx, adjacent, Fy, opposite. Oh, 39.6. No, what is it? Got one more. Hypotenuse. Good. What do you want to find first, Fx or Fy? I don't care. Fx. So A and H. Which trig function, Jack, my friend? Of course it is. What always goes next to the trig function? The angle. Fx over 39.6. How would I get the Fx by itself, Jack, my friend? How would I move that 39.6 over? Yeah, and we're also, it's technically one fraction equals one fraction, so my dumb trick of stuff moves diagonally still works, but the easiest here, I just go, oh, we're dividing by 39.6 times it over. So you're telling me, and I think you're right, that Fx is 39.6 times the cosine of 18? I agree, which is what? Do y'all get 37.662? And I'm going to pause. I see a number of you not typing on your calculator. That's not wise. Try these. Do you have a calculator here? Did you type it in? You want to get good at typing these in and figuring out where your calculator requires you to put brackets or a times sign or not. I know that I can get away without a times sign. In fact, I know that I can get away without closing my bracket. However, I also know that if I go cos 18 times 39.6, I've got a problem because my calculator is going to think that that 39.6 is in the brackets, which is why, Petco, you always see me whenever I write it, I tuck the number in front like a coefficient, and then I put the trig function. But these are things you can find out on your specific calculator. What was it? It was 37.662 units, Jack. What are we finding here? Newtons. Okay, I'm not writing a direction because the letter X implies horizontal. I could use, now that I know Fx, I could use tan, but then I'd be using Fx, which might be wrong, to find Fy. So, Jack, I'd rather use O and H. Which trig function? Sine? It's a sin when you say sin instead of sine? Yes? What goes next to the trig function? Angle. Fy over 39.6. I think it's going to be 39.6 times the sine of 18. I think I can just backspace and edit. Ha-ha! And I get, you get 12.237? And again, what we're saying here is if person A pushes to the right with 37.662 newtons and person B pushes down with 12.237 newtons, mathematically, Percy, that's identical to one person pushing at 39.6 newtons, 18 degrees south of east or below the horizontal. Those are mathematically identical. Where do components come in handy? Well, they're going to come in really handy when we look at projectiles, when we start throwing things in parabolic arcs. We won't deal with that parabolic arc because you need calculus. Instead, we'll break it into a horizontal motion and a vertical motion. But they also help us here. They can help us add vectors that are not at right angles with each other. I like example, what, blank? I forgot to put a number here. I like mystery example. I like mystery example. I like mystery example. Mystery example is a nice question. What do I like about this? Sky, can you read it to me? Out loud, loud and proud. Add. As soon as I see an actual angle with degrees in the question, oh, this just got much tougher. By the way, you're also noticing N is newtons, N is north. It's all context. W is watts, W is work, W is west. It's all context. So yeah, you got to read a little carefully. What do they want me to add? Well, I've turned the page and I see directions, so I'm going to do this. Oh, geez, that would have been weird. What's the first vector? Magnitude and direction. Loud and proud. And direction. Okay, so I'm going to dulp that. 14 west. Plus, and I'm going to have you repeat something. I'm not making fun of you. I'm emphasizing something, so I apologize in advance. Read me the second vector, magnitude and direction. Keep going. Magnitude and direction. Keep going. 24 newtons at? South of what? South of what? South of what? South of what? This is how we draw these, okay? Look at the last word. South of what? Draw a dotted line going to the west. Go back to the beginning of that dotted line. What of west? So I'm going to go down. How many degrees? Like that. And this line is 24 long, so it's going to be bigger than that 14. So that's how you draw these if they give them to you in a what of what format. The of blank is the dotted line that you draw, and then the word in front of it tells you which way to go from that dotted line. How do I add two vectors together? Draw them. And so one way to do this would be to go, what was the first vector? Magnitude and direction? Don't write this down. And then 24 newtons this way. And the resultant would be from the tail of the first. Change colors, Mr. Duke. To the tip of the second. And that'll work. Problem. Do I have an angle inside my triangle? Now, I could argue that this is 180 degrees, and so I could cleverly say, hey, this has got to be 150 because 30 plus 150 adds to 180. We call those supplementary angles. And okay, is this a right angle triangle? So SOHCAHTOA and Pythagoras don't work. You use the cosine law and the sine law. And if you're good at the cosine law and the sine law, you can do it, and I'll give you full marks that way. And I'll be honest, it's how I do it because I'm good enough at the sine law and the cosine law, much like Pythagoras and much like SOHCAHTOA. I can do that without writing anything down, all on my calculator in one step without writing anything down. Most of you are not at that stage. So instead, here's what we're going to say. Sky, do you see an angle? Did you say angle? Components. That's going to be a trigger phrase from now on. Did you say angle? Components. Is there an angle? Components. What I mean by that, Sky, is I'm going to break this up into, I guess it's newtons, so it's a force, Fx, and Fy. Good yawn. Fx, oh, sorry. Color. Fx, opposite, adjacent, or hypotenuse. What about Fy, FYI? 24? Yep. What do you want to find first, Fx or Fy? I don't care. Pick. What do you want to find first, Fx or Fy? I don't care. Pick. Fx? Which trig function? Okay. Cos 30 equals Fx over 24. So Fx is going to be, are you capable of going to your calculator without writing down 24 cos 30? If you write that down, can you know that you're going to multiply by 24? If you can skip writing out this little step here if you want, Kyle. I'm fine with that. Okay? So I'm going to go straight to my calculator and say, hey, it's 24 cos 30. 2 cos 30, Mr. Dewick. Nice try. You get 20.7846. And I'll carry some extra sig figs because I'm going to be using this to find an answer. So I don't want to just say 20.8. I've rounded off too much too quick. So 20.7846. Which trig function will I use, Sky, to find Fy, FYI? And I think this works out bang even, double check me, but it works out to 12 exactly, does it not? Yeah? if you go 24 sine 30. I know sine 30 is 0.5. I've done that one a bunch, so half of 24. So here's my argument, okay? Instead of going 14 plus 24, 30 degrees south of west, I'm going to argue this is the same as still 14 plus 20.7846 plus 12. I've broken it up into 3 vectors. Why is that nicer? Doesn't that make it tougher? No. Why is that nicer? Which 2 vectors can I casually add? Yeah. Oh, what if that 20.746 had been pointing east instead of west? Then, Jack, I would have just gone winner minus loser. Bigger minus smaller. Are they both in the same direction? Both in the same direction? So now I'm going to argue (34.7846) that this is really one vector that's 34.7846 long plus 12 long. And so I've taken 2 vectors that were at angles. Did I say angles? Turned one of them, the yucky ones, into components, temporarily made it 3 vectors, but now it's 2 vectors and they're at right angles to each other. So now I can, how would I add those 2 vectors together? Sky, draw them. (12) is roughly 1/3 of 34, so I'll eyeball it, make it about 1/3 as long. And the resultant goes from the tail of the first vector to the tip of the second vector. Where's the theta going to go? Bottom left or top right? Top right. Color, 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 color. And this is going to be the resultant force, Fr. It's going to have a magnitude of that squared plus 12 squared equals square root. How many you got that okay? Thumbs up. Yeah. Components. If you give me yucky stuff at angles, I can turn anything at angle. What if they gave me 2 vectors at angles? I would turn them both into horizontal and vertical components. I would add the horizontals, get 1 vector. I would add the verticals, get 1 vector, and add those 2 tip to tail. So I can turn anything into Pythagoras and SOHCAHTOA. If you want to do this one using the sine law and the cosine law and you get it right, I'm fine with that. But point being, you can survive just fine without it. I did put the sine law and the cosine law on your formula sheet, I think in the same section where there's a little picture of a triangle. But they're kind of redundant. They're shortcuts, but redundant. I like mystery example with no number. I like mystery example with no number. I like mystery example with no number. This is a nice question. Although this is harder than I would ever ask. Maybe on a quiz, but I don't think I'd give you one quite this tough on a test. But the concept is good. A plane's engine speed is 240 meters per second due east. I see compasses. I'm drawing a compass rose. A crosswind is blowing 125 meters per second, 40 degrees north of west. North of what? West. North of what? West. North of what? West. Okay. What's the plane's velocity relative to the ground? This is an airplane crosswind question, and Armand, I gave you this equation on your formula sheet. Jack, you've got it in front of you. What's the ground engine crosswind? That one. There's a V something plus a V. That one. Okay, so V, which way the engine is pointing, plus. Okay. And I'm irritated. I used the industry terminology. They talk about ground speed and engine speed and wind speed. Although it is clearly a vector because I gave you a direction, I really wanted to say engine velocity and wind, but I'll use their terminology. But I couldn't do it here for the velocity relative to the ground, because if I said velocity, what I'm really telling you is magnitude and direction. Okay. I guess I'm going to add these two vectors together. Let's gulp. Armand, what's the magnitude and direction of the engine speed? Yoink. Plus, what's the magnitude and direction of the wind speed? North of what? North of what? West. North of what? North of what? North of what? I'm going to draw west first. Going to go back to the beginning. Draw north of west. How many degrees? So 45 degrees is kind of halfway between 90. So a little less than halfway. I'll eyeball it. How long is this line? 125. Yoink, maybe about like that. Ish. Armand, is there an angle in this question? Did you say angle? Components. By the way, again, you could, if you're good at the sine law and the cosine law, you could say, okay, there's the 240, there's the 125, and the resultant will be from the tail of the first to the tip of the second. You can't use SOHCAHTOA trig, but you can use the cosine law. That would give you the magnitude, and then the sine law would give you angle theta, and it's all doable. But for now, let's break this up into components. So I'm going to break this up into Vx and Vy. That 125, opposite, adjacent, or hypotenuse. Thank you. What about Vx? I know why. I forgot. Color. Sorry. What about Vy? Okay, what do you want to find first, Vx or Vy? I don't care. Okay, which trig function? Sine 40 equals Vy over 125. So Vy is going to be, how would I get the Vy by itself? Multiply the 125 over. I think I can safely go straight to my calculator after one line of work. 120. I did say I was going to get you pretty good at trig, I hope. Certainly right angle trig. Do you all get 80.348? 5 sig figs is probably pretty good. 80.348? People nodding? Which trig function is Vx going to be? Which ones are you using for tan? These two? You can. I'd avoid that because if I got that wrong, Vy wrong, I'm getting Vx wrong. I would probably go with, which trig function might you consider? A and H? Now, have you turned the page? Did you write SOHCAHTOA at the top? Let me pause for a second. So maybe at the top we should have quickly have gone SOHCAHTOA. Which trig function? A and H? Of course it is. Vx is going to be, I can just backspace and edit. Cos. 95.755. That's weird. It looks like it's going to be a bunch of repeating fives, but then all of a sudden the pattern does change. So don't make assumptions in math. Things don't always repeat. 95.756. Are those right? Both of you? Everybody agree with me? Yeah? So now let's redraw this, but we're going to break it into 3 vectors. So I'm going to put a little equal sign to say, here's my new equation. I'm going to argue there's still a 240, but pointing upwards, there's an 80.348, and pointing to the left or west, there's a 95.756. Which 2 vectors would be easiest to combine without too much effort? My horizontals. Am I going to add them? Yeah, I think Armand, since they're in opposite directions, I'm going to go bigger minus smaller. And you know what? I'm going to use my answer button because I still have the 95.75 on there. I'm going to go 240 minus answer button because that's less typing and more accurate. And I get 144 which direction is the winning direction? To the right or east. So these 3 vectors can be rewritten as 144.24 plus 80.348. 80 is roughly half, a little more than half of 140. It's half of 160. So I made it about that big. Now how many vectors do I have, Armand? How would I add those together? Draw them? You don't say. So my vector triangle is going to look like this. Yoink. 144.24. Yoink. 80.348. And the resultant is from the tail of the first to the tip of the second. What am I finding? A force? No, a speed. Oh, this is V ground. I can even label it VG. Where's the theta going to go? Bottom left or top right? Color, 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 color. The magnitude is going to be... Oh, I'm going to use my answer button squared because I have the 144.2444444 sitting on my calculator here, so I'll use that. Squared plus 80.348 squared. Square root. I get a magnitude of 165, and now that I'm at my final answer, I'll go to 3 sig figs as my default for my final answer. Meters per second at opposite adjacent tan theta equals 80.348 over 144.244 2, 4. This is fair game for a quiz. For a test, there's so much writing here for one question. I don't know if I'll give you one with angles on a test like this. For a quiz, when you got more time, sure. Is that right? Everybody else? 165 meters per second at 29.1 degrees north of east, or at 71.97, the complement of that, east of north, whatever it is. So how do we add two vectors together? Draw them tip to tail. How do we subtract two vectors? We don't. We add the opposite. And Manchand, you're right. You really got to start thinking when you subtract a vector why you got the answer that you did. Are you getting wonky stuff on your calculator, Armand? Sorry? Is he getting wonky stuff? Okay, let me pause. Got one more? Yes. Last one. I got to number these. An object is initially moving at 6 meters per second due east. It accelerates due south at 3 meters per second squared for 4 seconds. Find the final velocity by using, remember VF equals VI plus AT? Everything that I taught you last year, Petco, still works with vectors. What? Yeah, it still works with vectors. So, Manchand, do you see compass directions in this question? I'm putting a compass rose. Do you see angles? Do you see something with degrees next to it and a north of south or an east of west or anything like that? Probably don't necessarily need components. What does it want me to find? Manchand, my friend? How? By going what plus what? What's VI? Magnitude and direction. What's A? Magnitude and direction. South. What's T? So what would 4A be? Not 3, but 12. Okay? This is going to have a magnitude of 12, but what's its direction going to be? Still south. My scale is a bit terrible. That 6 should be half as long as the 12, but I'll do that in my triangle. Manchand, how would I add these together? Draw them. 6 plus 12. I'm telling you, that red vector has to be V final. It still has to work. Where's the theta going to go? Top left or bottom right? Color, 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 color. What's the magnitude of V final? Pythagoras? 6 squared plus 12 squared equals square root. 13.4 meters per second at what happens to the squared? Small, yeah. So if you look at the units, we went meters per second squared times seconds one of the S's would cancel, and so now all we're adding are meters per second, so the units work. Good question. What was theta? I got 13.4 meters per second at 63.4 degrees. North of south, east of west, what of what? North of south, east of west, what of what? Is that south of east? Not east of south, it's south of east? Is it? Okay. Oh yeah, because the of blank is always the nice line. The thing in front is the slanty one that you had to get there. Okay. So everything that I taught you last year, Paige, still works. I can give it to you with stuff at right angles. I won't do that very often. I just want to let you know that the concept is still good. Is that okay? What's your homework? You're probably going to need to do these on a separate piece of paper because you're going to need to DULP. Draw a little picture. Number 1, add the following vectors. A, you can probably do in your head. What's 3 south plus 4 south? Okay, we'll just wait. Manchen, stay here and I'll come back. I'll bring that back up, but don't fall behind trying to catch up. So try 1A in your head. What's 3 south plus 4 south? 7 south. You can probably do B in your head, but C and D you'll need to DULP because now I see they're at right angles to each other. Number 2, subtract those. Okay. 3, find the horizontal and vertical components. And 4. So all those. It's 10 a.m. I might start the next lesson at around 10:45 or 11 or so, but you can also take a bit of a break if you need to now. It would be the good time to do your little bathroom runs and things like that, okay? Let me pause the video and then I'll take specific questions.